Hello everyone and welcome back to my video series on solving LeetCode problems. Today's video, this video is about problem 11, continuing with most water. So you're given an array height and like this, that has like the heights of these blocks here, red and black blocks. They're all black blocks, but the red is just to show something. And we want to find the maximum amount of water that we can fill with a pair of these two ones. So, what can we do here? So this solution for all of these heights is 49, because if you do the amount of water that can be stored with this pillar and this pillar is 7, because it's the minimum of the heights, and then 7 times 1, 2, 3, 4, 5, 6, 7, 7 times 7, 49. You can do 49 blocks of water. And no other combination of pillars, even though this one is the same size as this, because this one is 8, so 8 times 1, 2, 3, 4, 5, 8 times 5 is 40. It's not as big. So what's the solution? How do we get to the solution? The best way to approach this is, let's be like left and right. We start with this one and this one. We check what's the amount of water we can do. Okay, it's this amount. Cool. But we know that if there is a combination with this and this that makes it better, it can only be inside. And what is the logic here? So we just need to iterate the blocks to the left and this one to the right. We check which one is the smallest from both. And if this one's the smallest, you move this one to the right. And same thing, okay, good. And then you move it on and on. Why? JS Paint. Let's imagine you have it's just like the same amount, the same number of blocks. Actually not the same number of blocks, all the blocks are the same size. So you know that you compare the first with the last, and you create this amount of water. You know that if you do combinations with the blocks there inside, they will have a smaller length, so the amount of water will be less, and it only can be bigger if there are pillars that are bigger than the ones that you just compared to. So like this, it's the only way that you can have a better amount of water. So you can go from outward to inward. So let's code that. I already have the example set up. So left index is 0, right index is length of height. And so first of all we go while left index is smaller than right index. We say left val equals left height of left index, right val equals height of right index, and then we do the calculations. So looking at this particular one, actually let me just put a breakpoint somewhere else. Length of height minus 1. So left val is 1 and 7. So what is the best we can do with 1 and 7? So it would be 1 block of water, 2, 3, 4, 5, 6, 7, 8. So it's the index that we have here. and the index is 8 minus 0. So water equals right index minus left index multiplied by the minimum of left val. I'm not going to call them val, I'm going to call them heights, because that's what it is. Left height, right height. So this will be 8 because this is the minimum between 1 and 7. Okay, so best water equals, or let's just start with minus 1 because we'll never have negative water. So if water is bigger than best water equals water. And now we need to change the index. Either we change the left one or the right one. We must change the one that's smaller. So if we start from these edges, the smallest is the one on the left, so we change to the right one. And that's the right decision, because we get to this pair of pillars of indexes that will give us the best solution. So if left height is smaller than right height, we do left index plus equals 1, else right index minus equals 1. And then at the end we return best water, which in this case will be, it's going on forever. Why is it going on forever? 1, 8. Oh, right, index. Sorry. Best water is 49. Great, I am satisfied. I'm feeling confident. I'm going to submit. Okay. We have very good results. Hope you guys enjoyed this video. See you later.